So today's date is the 16th of January 2026, the 6th of 4:47 a.m. So today's OB's contract to Eze and Uche. So basically, this is for quantum tunneling. So basically, this is very important for one reason only: quantum tunneling. Quantum tunneling is the idea of measurement, but it's basically measurement. So if you have a quantum tunnel, you're taking a deep measurement, like basically quantum tunnels are naturally prone to collapse, but they're not unstable. Usually they're naturally prone to collapse, like a quantum, like but they're not unstable. So if you're up to my lepton configuration system, they're not prone to because the quantum tunnel is very stable, but it's just prone to collapse. It's not prone to collapse. It's not unstable. It's just prone to collapse. Because if you think about it this way, a quantum measurement is at an angle, any angle, but it's like any angle in that information plane. For example, if you're a lepton is is gravity, then a tenth of the gravity measurement. Gravity 9.8 meters per second, and upper force. Wherever you're trying to polarize, gravity 9.8 meters if something falls from a height of 9.8 meters. You have a dimension there. So this is just an informal proof of video of me doing showing you how it works. But the goal of this is just to get quantum tunneling down as a formal proof for it. Because quantum tunnels are stable. And how they're stable is because they work on the lepton field of gravity, like the curvature of gravity of space and time. And that's what stabilizes them. So, if you're riding a bike in one dimension, the bike then goes to another dimension, you get faster. You now have more properties. You then have to take different kind of measurement. And that's what you used to now. Basically, you're now in the movement state. For example, if I'm riding a bike on the earth and I go like, let's say 30 kilometers per hour, 30 kilometers per hour, which is like a car speed, car standard rate, but the bike speed is like 10 kilometers per hour. So you can go 10 kilometers, let's say 10 meters per hour, not kilometers, 10 meters per hour. 10 meters per second, per 10 meters when you enter some kind of district. That's just like the kind of, think of the district of dimension. So you got a bicycle district, 10 meters. You get a car district, 30 meters allowed, but maximum speed. But this year, so a car can go 30 meters, a bike can go 10 because it's about safety, and that's what I'm saying. Basically, the dimensions are the spaces you can operate. The bike can go as fast as a car, but it's not a safe thing for a bike to do. I like the analogy because the quantum tunnel. So it's like, if you have a weight, if I have an apple in my hand here, and I have a apple here, and I try to drop and I have a feather here, and I drop it, and I look at this is an observer, observing from 90-degree angle, they'll see, and there's no gravity involved, they'll see they'll see what we'll see, and that's the apple and the feather falling in the same rate. No, because there's no graviton in the model. So basically, the measurement you take is a referential, and that's why I'm saying angle, because I'm facing west. And if someone's facing me west, where they're facing? They're facing me from the south. And if I drop a feather and some kind of a dumbbell and the drop is similar, that means there's no gravity, there's no difference between my frame of reference and your frame of reference and what's happening. And that's to say gravity is a curvature system. So the quantum tunnel works because it's very stable, but it's prone to stability if something like a graviton is involved. And those gravitons, there's no explicit definition of graviton. There's no explicit graviton. There's a graviton model. And that graviton model is basically what stability is. This is called fermions. So the fermions are things that have mass and that hold mass. So basically, they hold mass and they work on energy, kind of mass and energy. But they hold mass, they have mass, they propagate as forces, like force equals mass acceleration. They work on the force subjects, they're fermions. So the fermions are the leptons, L for Lima, E for Echo, P for Papa, T for Tango, O for Oscar, N for November. Muons, which is 100th of a gravity measure. So that's 9.8 meters per second divided by 100. That would be 0.098 meters per second. That is what, if a lepton is 10, that's 0.998 meters per second. A lepton is 0.098 meters per second. And a muon is 1,000 of that, 0.00098 meters per second. So the goal of this is to see how gravity affects the system of nuclear, because it's just going to hold a tomographic state before via some kind of a sonar pulse. This is the medium pulse, So a triangle theory, for example, the goal of this is consensus bound because the bicycle is different. It doesn't go on the main road. It doesn't. It goes on the side with the car, and you can't drive faster than a car because you can drive faster than a car, but it's safe. So it's not just stopping you. If it's a 10 km, if it's a 30 km bicycle, it's really 10 meters. It's a standard limit. Because if you've got like to 10 meters, the maximum limit is 10 meters. That means all bicycles should have 10 meters, but then stop them from going in one zone. But if it's not a zone, you have less than 10 meters, and then you have 10 meters or more, then you can go 30 meters. But that means the car must not hit the bicycle because there are two tomographic states of movement of polar dimensions that must be respected because they have weight, mass, and configuration, tomographic configuration that we can measure. So, like I said there, quantum field theory works on bearing. So that is like a lighthouse bearing model I use. But I call it a bleep and a block system for quantum field theory. Because quantum theory, especially quantum tunneling, it's about the accuracy and precision of the measurement. So that's the problem. Accuracy and precision of the measurement. And those who need fermions to have a mass allocated, right? And before they have some kind of force which does the job because they have a mass. They don't need the cause and effect to have a mass. They just hold the mass. They are things that we consider we don't see, but just not like gravity. We take it for granted. That happened in the world. That just happened. Oh, we don't see it in gravity. That just happened. But we don't think about it because it's already there for the fermion to perform its job, and that is to have a cause, have a cause that can create some effect that has some force that dissipates as a force. So basically, this is an OBS. So you can model this as a quantum tunnel, and a quantum tunnel again is just as a policy, something that how accurate and precise your measurement is. Because accuracy determines how much you can, how close you are to your objective. Like the bicycle driving a car, and from a frame of reference, how close you are to your objective. What is going to the park or something, going to some kind of simple. Precisely mentioned how close were you to your objective. So what is the target placement? So what is your target? That's what because the quantum measurements quantum is about the measurement, not about the plane. Not about the leptons, not about the muons, not about the quarks, not about them. It's about the dimension of accuracy the system uses to perform quantum. So based on quantum field theory spin, because quantum field theory is basically the dimension. The quantum field theory is basically if you have nothingness, you have quantum foam, and quantum foam have quantum tunnels. So that's when particles pop into out and go to quantum tunnel, quantum field theory, and quantum field theory is quantum foam. Basically, if particles pop in out of nothingness, that means there's a quantum foam there, and that quantum foam means there's a quantum field, and that liquid has a tunnel that the stability is a quantum foam. Quantum foams are just particles and atoms that pop into existence where there's nothing, and that is the reality of quantum foam. So I'm going to tell you for the quantum field theory for the form. Because that's possible, because they're British. Maybe something got to someone, but he has to create some kind of state to this kind of reality before, or dimensions before he gets on those orders. Because that was how the system was set up. So that's what I'm saying. So it's a big problem because all these last but not least, so you got OB's control system. If OB builds something, OBR, if Oscar, B for Bravo, I for Indigo, build something, can break it. If OBR breaks something, can build it. So you have to, if OBI creates something, you can destroy it. If OBR reads suppress something, you can renew. And that's the part of OBR creates something, he creates something, and he can create some technically corn, technically cream, he can create food. He can destroy that food before you can eat him. So OBI can destroy food, yes, before you can eat him. So basically, this quantum field or something. So if you have an OBI contract, you are literally bound to. So everyone in sports responsibility, everyone must have a contract to be recognized by. Even JLS has to be questioned. That's how it worked in my head. We don't tell OBI to do a job. He doesn't own anything. He creates everything. He can destroy it. He doesn't have the power to create yourself or everything. If you own something and you give it to him and he can disassemble and reassemble, he can give you another thing that's no use, because he gave you something that you didn't create. But that thing can destroy it. Not give it that one, but he can create everything you can create. So if Richard says, "Oh, I made this and I love you," and he shares knowledge, Uche says, oh yeah, I share knowledge with you. Yes, and then Eze said, yeah, I share Eze with you. And Eze is king. And they both work with something. Uche can build them and break both of them. Obi is very powerful. And I am Obi. You know, Obi speaking, you know, but Obi, he doesn't want to destroy it. He wants to preserve what he made. And that's what we have to presume. So we have to go to a contract. And the contract must ensure that whatever the time you're using the phone, it is yours. You have ownership. So if you sign all this contract with him, you have to make a contract, some kind of negotiation with him, because you cannot negotiate on the terms of the reality you can. Because he's already gonna make something better, you know, and say, make it 10 times better, 100 times better, brand new, rebuild it, renew it. Okay, so quantum field theory, quantum form. Thank you, Namdi.